Happy morning, students. Last section we saw the physical properties of boron. Today we are going to see the chemical properties of boron. Let us see. Boron is non-metal, so it's a less reactive. Now see the reason. Size is increases, reactivity is also increases. Boron is small size, so it's considered as a non-metal and it is less reactive. But boron shows the reactivity at high temperature. Many of its compounds, that is boron compounds, are electron deficiency, that is BF3. You can take it as an electron deficient compound is BF3. And as an unusual type of covalent bond, many covalent bond we can see, BCl3, boron trichloride, many things. This is due to small size of boron and as a high ionization and high electronegativity with carbon and hydrogen. So boron compounds of boron are electron deficient. Sometimes it form a covalent bonding. These are due to the reason for this one is the boron possesses small size, high ionization, high electronegativity. Then first one, the formation of metal boride. Many metal react with boron forms a borides. Many metal reacts with boron form a borides. Except alkyl metal, all the group 1 metals are not react with boron. So general formula of metal boride, MxB1. The X is ranging from 11 up to 11. Y is ranging up to 66 or higher. Now see the preparation of. Now we are going to see the direct combination of metal with boron. When boron react with metal, this is chromium some metal react with n times of boron at 1500 degree Kelvin, it gives a metal boride, that is chromium boride. So boron is n times. Reduction of boron trihalides. Take a boron trihalides BX3, halides X3, react with metal at 1500 degree Kelvin in presence of hydrogen, it forms a metal boride. Now take BC. For instead of halogen, you can take a chlorine. Boron trichloride react with tungstens with hydrogen 1500 degree Kelvin, it gives a tungsten boride, that is metal boride, and chlorine plus 2HCl. So this 2 hydrogen will take a 2 chlorine, 2HCl. The remaining 2 chlorine is the Cl2. Then tungsten is metal and combined with boron, so metal borides. Formation of hydride. Boron not directly does not react with hydrogen, so no reaction take place. But it forms a variety of hydride is called diborane. The simplest boron is a diborane. Simplest boron is diborane. That is formula is B2H6. The other large boron can be preferred from diborane. For example, take a boron trifluoride react with sodium hydride. So it forms a hydride metal when boron react with metal. So now the compound of boron trifluoride react with sodium hydride. This one is sodium hydride. It forms a diborane. See the equation, BF3 react with sodium hydrate, it gives diborane and sodium fluoride. Again, the boron does not react with hydrogen, no reaction take place, but it forms a variety of hydrides, that is called diborane. The simplest boron is diborane. Formula is B2H6. Other large boron can be preferred from diborane. So many diborane we can prepare. For example, you can BF3 boron trifluoride react with sodium hydride, it gives diborane at 450 Kelvin. So BF3 react with sodium hydride, gives B2H6. How many boron is there? 2. B2. Hydrogen is 6. H6. Then remaining sodium is 6 sodium. Then fluorine also 6. 6 NaF sodium fluoride. Formation of boron trihalides. Boron react with halogen, it forms a BX3 at high temperature. Alright, boron react with halogen, it gives boron trifluoride. Boron trifluoride means BCl3, BF3 and BI3, then BBr3. These are halogens, so trihalides. Boron trichloride, boron trifluoride, boron iodide, boron bromide. Okay, the formation of boron nitride. When boron react with halogen, it gives boron trifluoride. Okay, the formation of boron nitride. For formation of boron nitride, now when boron react with nitrogen, that is boron burn with nitrogen at high temperature, it forms boron nitride. So boron is +3 charge, nitrogen is -3. So it forms a Bn, boron nitride. Now see here, boron react with nitrogen, it gives Bn, 2Bn. Then formation of oxides. The boron react with and heated with oxygen in presence of air or oxygen at 900 Kelvin. It forms an oxide. So boron react with oxygen at 900 Kelvin gives a boric anhydride. So the formation of the formation of, first we saw the formation of hydride. Next is formation of trihalides. Next is formation of boron nitride. Next is formation of boron oxide. So first one is boron react with, that is compound of boron, BF3. Boron trihalide react with sodium iodide. Sodium hydride, it forms a diboron. Next is boron react with halogen, forms boron trihalides. When boron react with nitrogen, forms a boron nitride. When boron react with oxygen, it gives a boric anhydride. Reaction with acid and alkali. Halo acids have no reaction with boron. That means HCl not react with boron. Boron react with oxidizing acid. Oxidizing acid means such as sulfuric acid and nitric acid and form a boric acid. With acid, boron react with sulfuric acid. It forms boric acid, H3BO3. Remaining, what is this? Sulfate. So sulfate will form as a sulfur dioxide as a gas. Again, boron react with nitric acid. Here, nitric acid, it forms a boric acid plus nitrogen dioxide gas. Okay, with acid, again, boron react with sulfuric acid, means all the acid, any acid means not all the acid, it not react with allo acid. With boron react with sulfuric acid, it forms a boric acid, H3BO3 and sulfur dioxide. Boron react with nitric acid, gives a boric acid and nitrogen dioxide. With alkali, sodium hydroxide. With acid, this one with alkali. Boron react with fused sodium hydroxide and form a sodium borate. Now boron react with sodium hydroxide, that is alkali. This one is alkali. It form a sodium borate. H3BO3. Instead of hydrogen, you are writing Na3BO3. That is sodium borate. This is boric acid. This is sodium borate or sodium boric acid. Not this is sodium borate and hydrogen. Okay, again repeat. Acid. When boron react with sulfuric acid, it gives a boric acid and sulfur dioxide. Boron react with nitric acid, it gives a boric acid and nitrogen dioxide. With alkali, when boron react with sodium hydroxide, it gives a sodium borate and hydrogen. Now see the uses of boron. Boron has capacity to absorb the neutron. So it absorbs the neutron. Then this one is boron. Isotopes of boron is 10-5. It's a moderator it is used as a moderator in nuclear reactor. If you take amorphous boron, it is used as a rock fuel igniter. The boron is essential for cell wall of the plants. Okay, now the compound of boron, that is any compound of boron, have many applications. What are the, for example, eye drops we can mix in this eye drops, antiseptic, washing powder, contain boric acid and boron. It contain boric H3BO3 and boron. In manufacturing of the boron used in manufacturing of Borax glass and boric acid is in this manufacture we are using boric oxide. Boric acid is B2O3 is used. Again you see the boron, uses of boron. Boron has capacity to absorb the neutron. The isotope of boron is 10.5, is used as a moderator in nuclear reactor. Amorphous boron is used as a rock fuel igniter. The manufacture of boron, that is we are using boric oxide, is used to prepare the Borax glass. Now it is essential, boron is used as essential for cell wall of the plants. The compound of boron have many applications. What are they? For example, eye drops, antiseptic, washing powder, and contain a boric acid and boron. The next is borax. The general formula is Na2B4O7 decahydrate. 10 means decahydrate. So what is the preparation? Borax is sodium salt of tetraboric acid. It is obtained from the elemental O by boiling with the solution with sodium carbonate. So first we are going to take the element O, that is Ca2B6O11, and react with the boiling with sodium carbonate. Okay, that is a solution of sodium carbonate. While boiling this one, you got the borax Na2B4O7. Na2B4O7. How many boron is there? Here is 6 2s are 12. Here is 3 4s are 12. How many sodium is there? 6 is there. So sodium also satisfied here. Okay, so 3 Na2B4O7. Here is oxygen is 21. Here you can see here how many oxygen is there. Here is 22. Here is 21. One more oxygen is there. Okay, now here see there how many calcium is there. 4 calcium. So 3 CaCO3. Take all the carbonate, 3 carbonate and 3 CaCO3. One more oxygen is left out here. Here is 2 hydrogen. Now combine with one more left out oxygen. So 2 hydrogen, 2 oxygen. It forms a calcium hydroxide. Now again I will repeat here. How many boron is there? 12 boron. Then sodium is 6. 3 Na2B4 and O7. 3 7s are 21. Here is 2 11s are 22. One oxygen is there. Here is water is how many oxygens? Here also 1. 1 plus 1 2. Hydrogen also 2. Forms a calcium hydroxide. Here is calcium carbonate. Carbonate also 3. Actually general formula of borax is Na2B4O7 decahydrate. So it contains tetranuclear unit. Then can write as a B4O5. The remaining is OH 4 times 2 minutes. This form is known as a prismatic form. The borax is exceed as a jeweler or octahedral borax or borax glass. The formula is a Na3B4O7, that is pentahydrate. The borax glass is Na2B4O7. Properties of borax. Borax is basic in nature. Its solution in hot water is alkaline. It dissociates into boric acid and sodium hydroxide. Now take the borax in water, hydrolysis with water. In hot water, it gives a boric acid and sodium hydroxide. Action of it. It forms a transparent borax bead. Now take a decahydrate borax, that is hydrate borax. So that is Na2B4O7 10H2O. On heating, it loses 10 moles of water. It loses 10 moles of water, means it became Na2B4O7. While eating this borax, it forms a sodium borate and boric anhydride. This two is a mixture of these two is a borax bead. Again I'll take Na2B4O7 10 10 moles of water, that is decahydrate. If on eating it loses the 10 moles of water, it forms Na2B4O7. Again on eating it gives a sodium borate and boric anhydride. The mixture of these two is a borax bead. The remaining, when borax react with the acids to form. So this is one is borax. Borax reaction with acid. We'll see next classes. Thank you.